thing to remember.
Yeah. Excellent.
So for those watching the recording, my name is Greg Schultz, and I'm at the Astronomical Society of the Pacific. I'm the Bay Area Science Festival coordinator or meeting moderator for this particular session. And we have three speakers that I'll introduce in a couple minutes or so. We're just waiting for a few additional folks to come along. It looks like we just added a few names, so I think we can get started real soon.
Mm-hmm.
All right. On the screen, there are some instructions, which I should just clarify a little bit. This is from the Bay Area Science Festival folks. We are not going to use the Q&A feature in this particular session, but we will have the chat window. For those of you new to Zoom, the bottom, if you drag your cursor over the bottom, you'll see a part where you can click on chat. So you can use that to to pose questions or comments.
Sorry.
Okay. And we will monitor that during the speakers' presentations. And if it's timely or important to a particular, at that juncture, we'll entertain that question right there, or we might wait till the end. It is a small enough audience. We might also, depending on how the presenters feel, they can open up to verbal contributions or questions at any point they are comfortable with, or if they just want to wait till the end. We want to save at least 5 minutes of each presentation's time for Q&A with all of you. So I'm going to be giving them some verbal cues, and also in the chat window, letting them know how much time they have left. Let me stop sharing this particular slide. And excellent, we have most of our pre-registered folks, I think, are here now. So let me show one other slide, which is the speakers. So you can anticipate who you're going to hear from today. So let me share that quickly. All right, do you see a chart with the names of the speakers?
Mm-hmm.
Okay. So we have Chrissy Murphy, Karen Roberts, and Ben Ashraf from these institutions listed here, all from up the Pacific Northwest way. And they're all, of course, in the environmental science health realm. And this may seem puzzling to folks why the Astronomical Society of the Pacific is organizing this type of a session, but we are an organization which is very interested in climate change and other areas outside of just astronomy. And we are, most importantly for this particular session, as we're partnering with some of our some colleagues that are also on this Zoom session right now that are that are covering other science disciplines. And so that's why we are the host for this session, and we're doing an astronomy one on Saturday afternoon at 3 o'clock. So if you're interested in this sort of science cafe session, look forward to that coming up on Saturday as well. Do we want to talk about annotation?
Yeah, and so why don't you go ahead and stop sharing? And so one of the things that we're wanting to do here, and so hopefully this is going to come up and do what it's supposed to. And so one of the things that we're going to do is we're going to try to make this be a little more interactive. And so what we're going to want you to do is we've got this. Occasionally, you're going to be asked to annotate on your screen. If you're unfamiliar with the annotation feature in Zoom, once one of our presenters is sharing, you'll see this sort of a thing up here where it says you're viewing whoever's screen. And right next to it, there's a little button that says view options. And then there's a pull down menu. And if you click on that, go down here and find the annotate. And if you select annotate, then it'll pull up this where you can add text, you can do stamps, and so you'll be asked to respond to a few of the things that's going on during the presentation. And so there's also going to be a poll during the presentation, and we encourage everyone to keep your microphones muted and your cameras on so our presenters can see your reaction and kind of gauge your understanding and your level of engagement that we're going on. So we would appreciate being able to see all of you. So thanks very much, and back to Greg.
All right. Yeah, I know that some folks you may be uncomfortable sharing your video, but if you wouldn't mind, we would love to see you all, but you may have some uncomfortable background or whatever you have. It's your choice, of course, but we do welcome seeing your lovely faces and reactions and you know, puzzlement or enthusiasm around some of the content that you'll hear about today. So anyhow, that's our words of encouragement in that regard. But we can get started with Chrissy Murphy from Oregon State University, speaking about finding new parasites on old fish. And we will have 18 minutes for each presenter, since we're starting at 6 minutes after the hour. And I'll give Chrissy the time warning a little bit later.
Thanks. Okay, so hopefully everyone already ate or has a strong stomach. I'm going to talk about parasites on fish today and tell you a story of how you very well may be looking at new things when you look at your fish. And part of that is that we haven't been looking at fish a lot for things like parasites. So I have a question for you and the quick annotation test to make sure everyone learns how to use this. So if you click on that annotate drop down, you should be able to stamp or draw or otherwise put an answer kind of around where you feel you fall in the spectrum. And I'm asking this not as a strict, you know, a lot means X number of times per week, but just how often you feel like you're interacting with fish. Some people interact with fish all the time. Some people never interact with fish. Some people actively avoid interacting with fish. I seek it out. So you just want to stamp or otherwise mark. Okay, so lots of sometimes. Someone likes fish a lot, and it's not me, so that's good. And there are a few of you that don't handle fish often at all. So I have another question for you, which is, as you're handling those fish, have you seen anything unusual? And this is meant to be vague. A lot of unusual things. So for those of you who have answered sometimes or a lot, you may have seen something that looks like these. So these are all different parasites. None of them will hurt you if you cook your fish. In fact, most of them wouldn't hurt you if you ate them raw, but there are plenty of reasons not to eat raw fish. They can be really important in good ways and bad ways for fish. And these are just some of the different appearances that you might see if you're handling a fish and you see a parasite on it. So you could have things that look like little spots. You can have big invertebrates that are in the mouth, on the surface of the fish. You can see worms inside their muscle tissue, or you can have kind of another example of these external parasites there with the Lernia. So I put the different types. You don't really need to know, but the big thing to notice is that if you see something on a fish that doesn't look like it's part of the fish, it probably isn't. And it's probably pretty important. So parasites can be a good thing. They're part of an ecological community. They balance what we see in the world. They, you know, in some ways keep fish healthy, just like parasites for humans are not all bad. But when they're introduced to new places, or when the environment changes and the balance of power shifts, they can become really problematic. And they can make fish quite sick. The risk is that as we live in a world that changes, these parasites will become more of a problem. And that's especially problematic when we don't know that much about them. So I'm going to talk a little bit about gill maggots, which are not as gross as they sound. They're only found in freshwater. They're distant relatives of sea lice, for anyone who's familiar with those. Both of them are basically really special copepods. And copepods is a big group of a type of arthropod. So they're somewhat like a little shrimp. And they're free living, most species, and they're really, really important food for fish. And then a few have specialized to be parasitic. And so I've circled there the specialized parasitic copepods on the gills of a juvenile Chinook salmon here in the Pacific Northwest. And this is pretty important because just like in the Bay Area, throughout the Pacific Northwest, we're really focused on getting our juvenile Chinook salmon alive and out to the ocean so that they can return as adults. So the place I'm going to talk about is the Willamette Basin. Just to give you guys a context of where that is, if you traveled north up into Oregon and through the valley is essentially the Willamette Valley, which is defined by this river basin. And it's a tributary to the Columbia River. So it flows out to the ocean between Oregon and Washington. The reason that we care a lot about this parasite here is that we've been seeing it on most of the juvenile salmon in our reservoirs, of which we have quite a number. We don't see it most of the time on salmon that are in rivers. And so the question was, is this something new? Is this something old? What's going on? And is this a problem? And increasingly, it looks like it is. What's interesting is that before this paper in 2015, no one was really even thinking about these parasites or collecting information on them. And so we knew that they were described from the Klamath Basin, which is closer to California, quite some time ago. They may have been here anecdotally, but there was no documentation of them anywhere in the valley. So we built a time machine. And by that, I mean, we went to a fish collection. So when you think about old-fashioned science, you probably think about people going out and collecting specimens. That is a practice that has continued, fortunately. So we have examples through time of individual fish. And what we can do is go back, essentially back in time, and check those fish for parasites. So we went back through and checked 1,200 fish that were all in the salmon family in our collection here at Oregon State University. And you guys have some really excellent collections very close to you in California as well. So I have another annotation quiz, which is, can you find the parasites? You guys are good. All right, so we'll show you the circles are circles of where they are. Yep. So you're all very good. You're all going to be hired. And if you look at these images, you can see that this whitefish, for example, in the bottom right corner was actually collected in 1953. So you just circled parasites that are almost, 70 years old. And there were quite a few of them. We found them on all of the what are called Pacific salmon and trout species. So that included cutthroat trout, rainbow trout, Chinook salmon. And this is really important because the more different fish they're on, the more widespread they're going to be, right? We also found them on whitefish, and that was not expected at all because whitefish are like a very distant cousin of Pacific salmon and trout. And so the circles are the groups that we found copepods on, and the X's we didn't. So we didn't see them on the char or European salmon and trout, which would be more closely related to Chinook salmon. So it's kind of like if you had some disease that was only shared by your second cousin, like how does that run in your family? Are these things actually related? And we don't have enough time to kind of circle and mark on this one, but hopefully you can see those arrows calling out the attachment appendage, which is really different in shape. So you get like a tube instead of a mushroom. There are like antennae that are shaped differently and little hooks. And functionally, what this means is that the one on the bottom, we have no idea what it is. It's not anything that's in the scientific literature. The closest relative looks like it's called Salvelinus mica. It's a species from Russia. So we have a parasite on whitefish, which is really common in the collection and has been here for almost 70 years at least. And it's new to us because we weren't looking. So this is my call for those of you that are handling fish, especially if you're handling fish that are not as commercial, you can totally contribute to science. We really need to know disease prevalence. We need to know what it's on. We need to know how often it's there. And there are probably a whole bunch of undiscovered ectoparasites.
2 minutes.
All around us. So there's a circle there. And I don't know if you can see those little strings on that fin. Those are actually a different kind of related parasite called an anchorworm. And we're just realizing that it looks like that came in on things like carp and are now infecting a lot of our warm water fishes. So as we see new introductions and changes in the environment, we're very likely going to see new diseases and parasites. And identifying them can help us keep our fish populations healthy. So if you find one, take a lot of pictures. To one of those pictures, add something you know how big it is. Identify and measure your fish. That's really helpful. And if you ever want to save something for genetics or identification, a really good way to do that can be to pop it in the freezer or to pop it into some high proof alcohol. And then there are fish health experts in the Bay Area for the state. There's also university fish health folks, and it never hurts to send someone a quick email with a few photos and ask what something is, because it might be something new. And there's another picture of an adult Chinook salmon with parasites inside of its mouth. And that's what I've got. So hopefully we can just talk about it and enjoy the fact that there are still lots of new things to find in the world.
Thanks, Chrissy. Go ahead and unmute yourself if you do have a question. It's a small enough audience. We can do this more casually than having to do formally through the chat. Unless you are in a noisy environment and would prefer to pose your question or comment in the chat window, that's also an option for you.
Well, fun trivia is that these parasites can actually pass bacterial pathogens, it looks like. There's emerging evidence. So they may function kind of like Ben's ticks, except for fish.
So how often do we find parasites? And I guess we mostly see ecto, meaning outside of the body, versus endo, inside. How often can we expect these when we buy tilapia at Trader Joe's?
You know, it really depends. And I would say if you're buying something farm, you'll see them less because often your fish are being treated medically. And there are some, you know, you can put in hatcheries here, they'll use things like hydrogen peroxide in the water. There are ways to treat disease and parasites in fish, they tend not to be something that you can do in a environmental, like outdoor setting. So it's really when you bring in anything that's not from a specific pond. So salmon, even if they're farmed, are much more likely to have parasites because they've been farmed in the open ocean. Something like the tilapia pond, they very likely are treating, but I wouldn't be surprised at the same time to see, especially like anchor worms or some internal parasites on those fish.
Tasty.
Christina, I was just wondering, have you seen any, or have you heard of any documented declines in population due to these ectoparasites? And if so, another question going off of that, do you see a decrease in, like, say, the economic impact related to, like, say, fishing on the fishing industry or tourism industry? Because I know people will come to go say, I want to go fishing, but if they're like, well, these fish have a bunch of worms, I'm probably not going to go fishing there anymore. And I was just wondering if you came across any of that.
So I don't think we know enough yet. There was the big paper many of you may have read about that came out of Washington State looking at a retrospective of those roundworms in the muscle tissue of salmon, for example. And it looks like they're becoming much, much more common. I have them. I bought frozen Alaskan salmon from a boat this year, and I find them frequently. I don't think we know how much that impacts people's purchasing habits, and we don't yet know the population impacts. That's part of what motivated our work, is that we think that at least for our area, where many of the Chinook salmon in the upper Willamette are rearing in reservoirs, that there's definite potential for this to impact the populations. And it may actually be what is limiting the populations at this point in time. And we're just trying to learn that now.
And for maybe one more quick question before we move along. If anyone else has anything?
I have something, one for you. Does it make you change how you eat fish? Do you eat fish?
Yeah, I totally eat fish. And no, actually, if you look at these under a microscope, they're much less disturbing, I think, actually, than they are with your eyes. Really, the best way to think about it is their close relative would be something like a shrimp. So they're really not adding anything that wouldn't be, at least for this taxa, that wouldn't be palatable in other circumstances.
Very interesting. Thank you, Christina. All right, we will move along to our next speaker. Karen Roberts from Washington State University is going to speak about modified RF waves and white blood cells. Take it away, Karen.
Okay, so we've got, let's see. Let's go and move to a slideshow here. So, and then we have our bloodstream here with our red blood cells. They carry oxygen. Our white blood cells fight disease. Our platelets cause clotting if we're bleeding. Plasma is a liquid that carries the whole thing, and the blood vessels hold it all together. So of our white blood cells, we have several different types. Our monocytes gather information about the thing that's coming in and invading, and give that information to the other cells. The eosinophils and basophils fight parasites like the tapeworms and roundworms that might be in your fish. And the neutrophils will fight bacteria like the Lyme disease that you might get from ticks. And then we have lymphocytes, where we have B cells and T cells. And so our B cells make antibodies, and they mark the infected cells that are infected with viruses. And then our T cells kill those infected cells, which prevents a lot of the viruses from being able to be produced. Interferon is a chemical that's produced by the monocytes, B cells, and T cells, and it has a multifaceted attack on the viruses, which is very helpful. And then our B cells, like I said, make these antibodies that attach to the outside of the infected cell, and then our T cells know how to find them. We have, oh, I was going to have you take a guess as to which of these cells might be affected by certain types of modified radiofrequency waves. So I don't have the poll here because, I do have the poll. Okay, so go ahead and give a guess of which type or types might be affected. So, all right, do we have everybody submitted, or some people submitted? Okay, go ahead and, well, I guess I'll go ahead and go on. Oh, here we go. So we have some people guessing neutrophils, some people guessing lymphocytes, and some people guessing monocytes. It's mainly the our lymphocytes are B cells, so which would make the antibodies, and so that impedes our ability to make as many antibodies. But it's not all types of radio frequency waves, so we don't need to be too concerned about some of the waves that we would be using. So like the viruses are killed by the T cells, and because if we mark them with an antibody, then we know how to find them easier. And one of the experiments to show that, or how it's nice to have more antibodies. So let's say that this jar is our blood vessel, and if I had iron filings, I would measure them. I just have wire nails here, so I'm going to pour in some wire nails into my jar. They're small. And those are going to be my viruses. Okay. And am I spotlighted? I could stop the share. Okay, there we go. And then for my plasma, I'm going to use some salt, because I have a hard time finding those. Okay. So we've got viruses in the plasma here. And so just, I'm going to go ahead and take one magnet, and I managed to mark a few of those viruses, make it easier to find. If I take two magnets, here, then I can get more, and I'm just going to put those to the side and count them later. And if you use 3 magnets, then I get quite a few more. And that we're getting to those infected cells before they have a chance to make more viruses, and so we're really getting on top of things. Share. So when I did this before, I got, this is the amount I got with 1 magnet, and then more with 2 magnets, and then quite a bit more with 3 magnets. So I was able to get 6 with 1 magnet, 28 with 2 magnets, and 98 with, so we can see the importance of having a lot of antibodies. And so normally our bodies would be making 200 or 2,000 antibodies per second. So that's pretty efficient immune system. So, and the place where we have that problem is during mitosis of those B cells, and each one of these steps takes chemicals and chemical receptors. And so if there's an interruption in either the chemical or the chemical receptors, then this mitosis doesn't take place. And so we don't have the replication, as much replication as we would have without that interference. So some main radio frequency modulation types is amplitude modification like AM radio, frequency modification like FM radio, digital, which are pulse code modulation, and phase modulation. So with our amplitude modulation, we have our signal we're trying to send, which is a modulator, and our carrier signal, which helps us send it. Our amplitude modulation, we're changing the height, and the frequency modulation, we're changing the space between peaks. And then this is about to move. So you have an idea of how that carrier wave is sending that modulated signal. We also can use phase modification. This is basically taking a frequency modification. It's sort of slowing down the whole thing and shifting it. So we have our highest frequencies, our strongest signals get shifted off to a place where they're not quite as strong. And then this is a much safer all around type of signal. And then we have different types of pulse modification. This is where we get our digital signals from, our pulse code modulation. And then quite a few different types of signals, also some pulse position modulation and pulse frequency modulation. So the one we want to stay away from is actually the one that's been around the longest, is the amplitude modulation. And we've been playing with this one for 100 years. And so people get the idea, oh, we'll just use amplitude modification because we've always used it. But we do have some better things that we could be using. And some of the carriers are moving away from amplitude modulation and using some of the other forms that are much better and also produce a much better sound, because amplitude modulation can produce that popping noise that's really annoying when you're listening to something. And so it's really not the best signal, whereas the other ones are more clean. Your frequency modulation gives you your faster downloads. And that's also a nice signal for us to use, and also not something that's shown to be a problem. This is how long we've used amplitude modulation. Since 1927, we've been playing with it. So this is something that has continued to stay in, but again, some carriers are moving away from it. So some things we can do is stay 5 feet away from the Wi-Fi transmitters that are in our homes or offices, 1 mile away from cell towers. Check what type of RF modulation your carrier uses, if they know. Most of the people there might not know, but like I said, some carriers are moving away from it. We need to get more carriers moving away from the other signals. And then if you are someplace and you're hearing a lot of poppy noises and static on your line, you're probably in an area where you're getting some bad signals. And those are just not annoying to listen to. Those are signals that are potentially causing some problems. So, but what actually weakens the immune system the most are things like stress, lack of sleep, loneliness, disease, poor nutrition, and then genetics. Some people are better at fighting off parasites, and some people are better at fighting off viruses, depending on the way their genetics are wired. So, that's really what I have. Let's see. Do you have any questions? Martin has a question.
Yeah, if you can go out of the presenter mode, then you can see us again. I see only the presentation at this point. Yeah, I was wondering, you said something about be 5 feet away from the Wi-Fi signal at home or 1 mile away from a cell phone tower.
Right.
We have very little control over being 1 mile away from a cell phone tower.
Right.
And sometimes not even being 5 feet away from the Wi-Fi router. How big is the problem in your mind?
It's more of a problem where it's being modulated, which is at the cell phone tower, rather than where it's demodulated at the Wi-Fi transmitter. So, so the Wi-Fi transmitter is not really as big of a deal. It doesn't tend to attenuate at all for 5 feet. So you're getting that strongest signal within the 5 feet. But, and then also at your phone or computer, possibly it's not really a very strong signal there. It's mainly at the cell tower. If we get more cooperation from carriers in switching over to some of the safer forms of modulation, that's going to be the biggest thing. because I know that, they put up a cell tower, like right next to the freeway, and I'm just looking at this as like, well, this is probably not a good idea, and next to a strip mall, and but yeah, so if we get more carriers over, and maybe we can influence it just by our purchase choices and what we decide to do. So that's just one way to handle it.
Thanks.
Other questions for Karen? Is there a lot of pushback on placement of cell towers? Or I'm not aware of a lot. I know that there's people concerned, but I don't know if it's causing any slowing of cell tower placements.
I don't think so. I know that some people get concerned about beautification, the environment. They don't like a cell tower there where they used to have a nicer view, or that type of thing probably tends to be more of a concern. Other than that, there haven't been very much. I mean, other than people getting quite upset, but there hasn't really been that much of a pushback as far as building them. Yeah.
Probably get that question a lot, and then I shut up because others might want to also ask the question.
Yeah, so one of the problems is because we're moving to faster downloads, we're using that frequency modulation, which doesn't, and those don't travel as far. And so we need to have the cell towers in more frequency. And the frequency modulation itself is not a problem. It's just the fact that if we have other forms of modulation in there along with the frequency modulation, then that becomes the problem. So we need to be mindful of what it is that we're putting along with it.
I have a question.
Okay.
Why are those specific lymphocytes more affected than other cells in blood?
Probably because it's working with something that's so small. Antibodies are extremely tiny, and like a monocyte is pretty big, and so we're not going to really affect it very much. I mean, even if a dendrite is actually, as far as cells go, it's pretty huge, and so we're and eosinophils. I mean, they're fairly large. It's just they're just too big for that kind of thing to affect. Whereas a B cell is really a very small thing, and it's a very small process, so it's much more likely to have an impact.
I can't help it. How far do you live from a cell phone tower?
Sorry. I don't live very close, but I am in a rural area. And so my choices as far as carriers is really not good. So, and the things for rural areas, we wanted to travel further. So unfortunately, a lot of times people will choose to add amplitude modification in order to reach rural areas. And I don't have a choice. So, so I'm not in a urban area where I've got a variety of choices and I can pick and choose and have some nice options to go with. So that's where I'm at, but I don't have a choice about it. Yeah.
So if somebody shows up offering us money to put a cell phone tower on our property, we should also ask them for robust health insurance to go along with it.
Yeah, or just have maybe some more information as to who is going to be using the cell phone tower and what type of modulation they tend to use. So yeah, because there are carriers that aren't using it. So some.
The exposure to the this type of these waves, is it just additive? Is it scaled in any long? How much exposure do you need to actually have harm?
And we don't really have that information. We don't have good information on that. And even the studies back in the 1990s, where they were very extensive about it, they did not give information on how much exposure. And then the newer studies, a lot of the information is mixed. So so we need to have more controls in the studies so we know what exactly it is that we're testing. And that hasn't been really good.
I was going to ask a question about basically that, like how concrete is the research, and what is it in a form that you can actually use as a battering ram, you know, to the.
Right. But I mean, a good thing would be for OSHA to step in, the Office of Safety and Health Administration, and decide what levels are too much, and then that would give us some good regulation.
Mm.
But that would require more consistent data so that they have some numbers to go off of.
Mhm. Fascinating.
Yeah,
But that's a
yep.
good question. Thank you.
Yeah, we have time for another question. Maybe before we move on, is anyone else?
I always have questions.
Go ahead, Martin.
And that is the epidemiology of these things. What is the data saying? I mean, you presented us with a mechanism for how this can actually be damaging. But what do the epidemiological data say about people living around cell phone towers? Because that's the strongest signal, right? That's where they're sending it out with power.
Right.
And so if somebody said, is there any, because I remember I was part of the anti-nuclear power movement. And there was always the question, right, about how living near a nuclear power plant is actually epidemiologically a problem. And the same is probably true here. Can you, is there anything there?
Is there a higher death rate? Is that what you're asking?
Or some incidents, something that you can see that shows kind of in the field effect, living near cell phone towers?
I mean, I can see the problem. We have a higher death rate just outside of the urban areas, but close to the urban areas. But it coincides with some carriers and not with other carriers. And it's kind of scary to look at it, but it's kind of like, cause like, oh, well, this carrier doesn't really seem to have this problem at all. And so that's kind of refreshing to realize that, but then it's kind of creepy to look at the other ones and go, oh, this kind of matches. So there is some of that, I do think, but I don't want to get too political and point fingers. So.
Thank you, Karen. That's great. All right, we're gonna move on to our last speaker of the three this evening, and it is Ben Ashraf from Oregon State University, speaking about how the environment influences our risk to tick diseases. Take it away, Ben.
All right, thank you so much. I just want to switch into presenter mode. All right, so is everyone able to see my presentation all right? Okay, so I just want to talk about how our environment influences our risk to different tick-borne diseases. Now, this was a part of my recent dissertation, so I'm just going to give you a snapshot of it. I want to start off with a quick knowledge check exercise, which is going to be pick the tick out of the random pictures. Then I'm just going to give you some quick background information about ticks and their associated diseases. And then I'm going to tell you a little bit about my research. And then I'm going to end on some prevention efforts or prevention methods that you could use to better protect yourselves moving forward. So I want to start off with, can you guess the tick? So if you can all just take a moment to go to your annotate function and select the images that you think are the ticks in the picture, I will be grateful, and I'll give you a moment to start out. Well, everyone's still working? All right. So it looks like that you all did really well. No one selected the giraffe, which is a good point. So good job, everyone. You know what a giraffe is. I think everything is all right. Actually, the middle picture below is not a tick. That is actually, for anyone who knows, that's a poplar weevil. So for all of you entomologists out there. Now, the reason I want to show this to you all is just so it reflects the nature that ticks can be very small. They can come in different shapes and sizes. So it's important to be aware of this because ticks throughout their life stages can transmit different diseases to us. So I'm going to move forward. So I'm just going to do some quick background of the black-legged tick. So even though that there are several different species of ticks and some of them do transmit different diseases, I focused my research on the black-legged tick, and otherwise known as the deer tick. For some of you may have heard those names interchanged. Now, the reason for this is that this particular species is a primary vector for several human diseases in the United States. there are two distinct species of black-legged ticks within our country, the eastern black-legged tick and then the western black-legged tick. And I'm sure from those names, you can have a pretty good guess of where these species live in the country. And I'll go over that in the next slide. What's important is that for both species, they each have around a 2-year life cycle, as you can see from that picture. And then you can see that they can get quite small, especially when you get into the larval stage of the tick. And as I said before, since these ticks can transmit the diseases throughout their entire life, throughout their various life stages, it's important to be aware of this as you go forward. So, as I said before, that we have the eastern and the western black-legged tick. Now, these ticks do reside obviously on the eastern and the western half of the United States. But what recent research has shown is that these ticks have been progressively moving more into other states as time goes on. As you can see from those maps, the one on the right hand shows the distribution of both species between 1907 to 2015, and the one on the left shows 1907 to 1996. As you can see, the eastern black-legged tick has actually progressed quite far into the Midwest regions and even into some of the more southern states such as Texas, Oklahoma, that they really weren't as far in the back, let alone in 1996. So now I want to take a moment to talk about the diseases. Now we heard I'm sure all of you have heard about Lyme disease, but I've also, in my work, I tried to focus on babesiosis and anaplasmosis. For those of you who don't know what babesiosis and anaplasmosis are, babesiosis is a protozoan disease that's usually transmitted by the black-legged tick, and it also can be transmitted through other means, such as vertically from mother to child, as well as through the blood supply. And anaplasmosis, it's like Lyme disease. It is caused by a bacterial infection, and for the longest time, it was classified as human auriculosis. So you may have heard of someone contracting auriculosis in the past, but it was not until recently that these diseases were actually found to be two separate species of bacteria, and they decided to split them up into auricula and then anaplasmosis. What's important to know about these diseases is that reported cases have shown an overall increase throughout the United States in recent years. Now, this could also be due to some other factors, such as better awareness of these diseases through time. But this does raise an alarm in the public health sense, that we're seeing this steady increase in cases over time from all three illnesses. Also, another factor to consider is that all three of these illnesses go unreported in several instances. And most often this is just because unless you're immunocompromised, I'm just using babesiosis as the case, you really don't display adverse symptoms to babesia. It's only when you're immune compromised that you start developing more severe symptoms. So it may be mistaken for, say, something like as a bad flu or a bad cold. So now the question is, what can be done? Well, we know ticks are influenced by the surrounding environment. If you look at factors such as the physical environment, forested regions, most people know, like when you go out for a hike in the woods, when you get home, you should probably check yourself for a tick in the eastern half of the US. Also, we know that local demographics play an important factor in this. For instance, I'm going to use individuals who are 65 and older. We know that individuals who are 65 and older are more likely to be diagnosed with a tick-borne disease as compared to those who are a little younger in age. So what else is an important factor is that little work has shown that the commonality of these factors between diseases. Now, this could be under the assumption, well, hey, it's the same vector, so why doesn't it most likely be if factors affect the vector? That would be what's of interest. So there's really little work that has gone into, what are the common risk factors for all three illnesses? So I attempted to address this question in a part of my dissertation by determining the common associations between select environmental and demographic factors and the annual reported incidence of all three illnesses. So how did I go about this? Well, after receiving the data on reported tick-borne disease cases for 11 states, I divided the number of cases by the county that they were reported in each state. Now, this ended up being around 332 separate counties throughout 11 states in the Northeast and Upper Midwest regions. Afterwards, I found a lot of spatial data in respect to environmental factors such as temperature, elevation, forested regions, as well as some demographic data pertaining from the U.S. Census and other sources. And what I proceeded to do was to create models for each infectious disease based upon all this data, and to try to determine like what are the common factors across all three illnesses. So, what about my results? Well, at first, what I wanted to do was show, in this first images, I want to show the actual difference in annual incidence for all three illnesses between my study period of 2011 and 2015. So if you see, look at all three maps, you can see that there are certain areas which shared a common annual decrease in the incidence of all three illnesses, and vice versa, where you see regions such as the Northeast, where you see counties that had an annual increase in the reported incidence of all three diseases. So this shows that there's similar trends going on as far as reporting of these illnesses throughout different states over this time period. When I actually conducted the modeling of these illnesses, I found that a total of 6 factors were found to have a common relationship with each disease. Now, these factors included certain environmental factors, as well as different demographic factors. What was interesting, though, is that I found that there were certain differences. In the case of babesiosis and Lyme disease, it was found that rural counties had the largest positive association with the annual disease incidence for both pathogens. And on the other hand, anaplasmosis, it was found that annual median income had the largest positive association with annual disease incidence. So this goes to the heart of that question, that there are differences among each pathogen, and that's important to consider when you're moving forward as far as planning prevention efforts or as far as directing health resources in respect to preventing these illnesses. Because you can't say, well, all these risk factors are common across all three illnesses. No, there are certain differences that you have to take into account. So what are some of the key points? Well, one of the key points is that we found that most risk factors held a common significant relationship with the incidence of each disease. And we found that both median income and rural counties report the largest positive relationship. So my hope is, though, that these models are not technically complete. There are still additional factors to consider that I was unable to do in this initial study. So the hope is that with additional work is that we'll be able to gain a better understanding of the shared factors with respect to the incidence of different tick-borne diseases. So I have a question for you all that I was hoping to ask.
2 minutes.
Oh, well, why would such knowledge be important with respect to preventing these diseases? So I'm going to move on really fast. So I got a quick question. In your opinion, how do you think we can stop additional cases of tick-borne diseases? Can I have someone actually just shout it out, because I don't have time for any annotation? Anyone? You have to unmute yourself. Prevention? I heard prevention, and that's exactly right. So there's reasons for that. Unfortunately, we don't have a current vaccine for any 3 illnesses, and antibiotics really don't prevent infections. They're only there to treat infections once they happen. So for those of you who guess prevention methods, you're on the spot. So I got a few prevention methods that I'm going to quickly list off. Know where to expect ticks. We talked about forested regions, taller grass. Use appropriate tick repellent when going out. Check yourself and pets for ticks once you come back. And also take a shower soon after being outdoors, because if you do have one of the little guys on you, it can quickly wash off in a shower. And there's studies have shown a decrease in disease incidence with taking showers. So to answer my earlier question about how would my research potentially help prevention efforts? Well, if you have a better understanding of the common relationships across these illnesses, it may allow you to better identify certain locations that are at increased risk for these diseases. And then if you have knowledge of these locations, you can better direct your health resources in a more efficient manner, which is something that's always important when you're relying on government budgets and such. You have to be frugal with your resources.
1 minute.
And in conclusion, I just want to finish my presentation by thanking you for taking the time. And I want to also acknowledge the efforts of my advisors and other collaborators on this project. And I'm ready for questions.
Excellent. Is there anything, point that we rushed you through that you wanted to make finally?
No, I mean, the main point I wanted to say is that it's important to consider that prevention is truly a key to preventing these infections. A lot of people rely on like, hey, when can we develop vaccines, or rush to say, oh, I want antibiotics for these illnesses. But the idea is that we have to use education as our first line of defense against these and other vector-borne illnesses.
Any questions? Again, you can unmute yourself and just speak out loud. You have a question for Ben?
I have a question, Ben.
All right.
You speculate on the relationship with median income. That's like, it's really interesting. How does that relationship look? Is it that lower income, you're not going to the doctor and getting diagnosed? Is it that you spend more or less time outdoors?
Well, that's a great question, Christina. There's a couple different reasons for why median income might be related to increase in vector-borne diseases, in particular tick-borne illnesses. Some could be that you do have extra money where you can go out and receive and look for treatment when you're feeling sick. When most people, if you don't have enough money to go to the doctor, you might like wait it off and think you can beat it on your own, or wait until it becomes more severe. Another potential reason is that people with money, and it was an interesting study that they did in New York City, where they found that people of higher median income were contracting tick-borne illnesses at a higher rate. And they speculated that these people in New York City who had higher median incomes were able to go traveling to the wooded areas at a greater frequency than those who might be of less means. And then therefore, if they're exposing themselves, they may be more likely to contract illnesses. And you can make the same argument that people may be fleeing inner cities who have the means to purchase homes in the nice suburbia areas, or even in the more rural areas. They might be fleeing these more urbanized areas where tick diseases are less prevalent. That's a great question. Thank you.
Do we know that some people with less means might just be treating the ticks themselves and not reporting it?
Well, I'm really not aware of any available data on that.
Okay.
It's quite possibly that some people, they're like, well, let me just, if they're more frequently exposed to tick-borne diseases, they might be like, oh, well, I got it off fairly early. I'm not going to be worried about it, because they've shown the quicker you take off a tick once it's attached, the less likely you are to contract an illness. So they might be more aware, and they might know when, like, what makes them at a higher risk of contracting an illness.
Okay.
Yeah. But that's a great question too. Thank you.
Okay, sure.
I have a question that
Yes.
I'm wondering whether people suggest that. I know that on the East Coast, particularly where mosquitoes are very common, they spray. And of course, they're spraying I'm not sure they're spraying because of ticks as well. And if they do, what is your assessment? There's behavioral changes, and we should look at ourselves, maybe stay away, have long socks and long clothing when we go out, and all the usual stuff that outdoorsy white middle-class people know how to do, because they are more outdoorsy. We know that. Like, you're right about.
Yes.
I work in that field. But what about spraying? What do you know about spraying, and what risk does that potentially entail, or benefit? Benefit.
There are certain benefits to using a acaricide in respect to ticks. There have been studies looking at the 4 posters device with respect to tick prevention, where basically they have deer feeding stations, and they apply acaricide to the backs of deer, which are one of the reservoir species for ticks in the eastern U.S. And that's shown to be highly effective. But the real question becomes the cost benefit. Over time of supplying deer with enough food materials to last them over a long time can be quite costly, especially for when you think of different counties that may not have the budget to support this. Also, you can also spray your yards as individuals. But then, when you consider that some people are a little hesitant to go using chemical sprays on their yards, that raises the issue of like, is this truly effective to achieve a long-term decline in the tick population? Thank you for the question, though. I appreciate it.
Other questions? And we are right at the top of the hour. I'd like to maybe get another question in, especially invite any of those if you hadn't had a chance to ask a question just yet. This is your last chance.
I can't help it. Have you
It's
ever
all right.
had a tick-based disease yourself?
No, I actually didn't have a tick-borne disease. I actually grew up in West Virginia, which is surprising because I did spend some time in the woods growing up. But no, I've just always been interested in vector-borne illnesses, and it's just that interaction of how we interact with the local environment and how that increases our risk to infectious disease, and that's what got me interested in the subject and why I pursued my doctorate in public health.
Excellent. Okay. Thank you, everybody, for joining us today. I know we want to respect everyone's time. We hope that you can join some of the other events happening here with the Bay Area Science Festival. And in particular, we're doing a similar session in astronomy topics again on Saturday afternoon at 3 p.m. And I hope you can join us then. Thank you to Chrissy, Karen, and Ben so much for today. Yay.